Change the order of integration for the double integral I equals integral minus a to a, integral 0 to root of a square minus y square f of xy dx dy. First of all, we have to identify the boundaries of the region inside which we have to perform integration. Looking at the given double integral, we have x varies from x equals 0 to x equals root of a square minus y square. When you consider the upper limit x equals root of a square minus y square and square both sides, you will get the equation x square equals a square minus y square, which can also be written as x square plus y square equals a square, which represents equation of a circle whose center is at origin and radius equals a. From the given double integral, we have y has variation from y equals minus a to positive a, which would mean that the circular region towards the right of the y-axis bounded by y equals minus a and y equals a will have to be considered. We have x equals 0 determines the y-axis, therefore this is the semicircular region which is the required region inside which we have to perform integration. Notice that if you draw a horizontal strip here, the horizontal strip has its left end at x equals 0, which is the y-axis, and right end on the circular part x equals root of a square minus y square, which is this circular part. This horizontal strip will have to move from y equals minus a to y equals positive a in order to trace the complete region in which we have to perform integration. Now, since we are asked to change the order of integration, we will have to first find out limits of y. For that, we have to draw a vertical strip. When you draw a vertical strip, notice that the bottom end of the vertical strip is lying on the part y equals negative root of a square minus x square, and the top end of the vertical strip lies on the part of the circle which is the curve y equals root of a square minus x square. We have found the equation of the circle x square plus y square equals a square. When you write y square equals a square minus x square and take square root on both sides, we have y equals plus or minus root of a square minus x square is obtained. We have this region of the circle represents the curve y equals positive root of a square minus x square, and this part of the circle represents the curve y equals negative root of a square minus x square, and thereby we have obtained the lower and upper limits of the vertical strip. Lower end is at the curve y equals negative root of a square minus x square, and the upper end of the vertical strip is on the curve y equals positive root of a square minus x square. Now, in order to trace the complete region, which is the shaded region, we have to slide this vertical strip from x equals 0, which is the diameter part of the circle lying on the y-axis, till x equals a. That is, the vertical strip first of all enlarges to become the diameter of the circle and then keeps on shrinking until it shrinks to the point a0, which corresponds to x equals a. Hence, we have the equivalent double integral after we have changed the order of integration will be this one.